called Atanasova, so I don't know what the probability was of that. But just to explain the background, my name's Dominic James. I'm a medical student at Plaza University in Bulgaria, and the research has been done by Dr. Naydenova, who's at the back, who will answer any questions you may have. So the research is about genetic markers of coronary artery disease risk. And this one's to send it forward. I was just trying to work out if the...
Okay. Yes.
Oh, there we go.
Yeah, this is forward. This is
Okay.
forward.
Fair enough.
Okay.
So this one...
And this is
The other way.
Laser.
Okay.
This is laser. This is
laser.
This is
Okay.
forward. Yeah.
Okay. Right, so this is a piece of research on coronary artery disease, looking at the genetic variant CYP2C8 in the Bulgarian population. It was a case control study to determine whether the common genetic variation CYP2J27 in the related gene was associated with the risk of coronary artery disease. I haven't got the hang of this, sorry. Is that one to go forward again? Just that one at the back?
Yeah,
okay. Cytochrome P452C8 is an enzyme responsible for the biosynth of vasoactive substances from arachidonic acid, and it's expressed in the vascular endothelium, and it metabolizes, as you can see at the bottom. The study was done analysing 99 patients with CAD and 377 controls to look for the potential polymorphism. And to evaluate the genotypes, the samples in real time were done with PCR with TACMAN SNP genotyping assays. And at Hardy-Weinberg equilibrium, the deviation of allele polymorphism was CYP 2J27 and 2C83. And the chi-squared test was used for the frequency of the T allele. In terms of the study group of 99 people, there was a spread of 60 men, 39 women, and you can see information on the amount of smokers. And there's a couple of people with type 2 diabetes, 25 with type 2 diabetes, for example. The percentages are on the right. These are the clinical characteristics of the group. You can see BMI, triglyceride levels, cholesterol levels, etc., slightly higher than average. Deviations on the right. This is looking at the group with coronary artery disease versus the control group. And you can see from the table various statistics. And it looks at the TT, TG, and the combination alleles and the GG at the bottom. And you can see the difference between the control group and the group with coronary artery disease. What's interesting to note is the percentage of the T alleles is just slightly greater in the control group, 14.14 versus 12.1%, and the frequency of the presence of the T allele was greater in the group with infarction than in the control group. And those figures were in the previous table. The p-value for the statistical significance taken into account Hardy-Weinberg equilibrium is greater than 0.05 and cannot be rejected for the hypothesis. And we can see a similar type of table as before, comparing the frequency of genotypes CYP2C83 and looking at the group with coronary artery disease versus the control group. And what you can see here, you have the resulting p-values, indicating the T allele CYP2C83 with high probability lies close to Hardy-Weinberg equilibrium. And if you look at gender and the likelihood of CAD among the polymorphisms, you can see that in the table information to come. So this looks at whether you have coronary artery disease and whether you have the presence of the T allele. And you can see the yes, no, and the totals as per the table. The p-value is 0.37, showing that the hypothesis of no association cannot be rejected, and the odds ratio is 1.35. So there's no evidence for association between the T allele and coronary artery disease. If you look at the T allele CYP2C83 with, for CAD, the obtained p-value is 0.04, showing the hypothesis of no association has to be rejected. If you look at gender and the likelihood of CAD in this study, we see the results in the coming tables, and the obtained p-value is 0.8 and the odds ratio is 1.18, showing that gender is not a risk factor for CAD. If you're looking at the T allele CYP2J2 7 carriers. Gender and CAD, you can see whether they have the T allele, whether they have type 2 diabetes, and it's a comparison for the two alleles, firstly CYP2J27 at the top and CYP2C83 at the bottom. And the analysis shows that gender is not a CAD risk factor among the T allele CYP2C8.3. And this is looking at gender and the likelihood of CAD among the participants without T allele polymorphism. And you can see from the table, presence of the T allele and the hereditary nature and the total of the 99 participants and how the distribution is made. The statistical parameters P is 0.10 and the odds ratio 1.49. It's unlikely that gender is a risk factor for CAD among the T allele CYP2J2 7 carriers. And this is a simple table showing the gender and the coronary artery disease. It's unlikely that gender has an influence on the CAD chances among T allele CYP2C83 carriers. And this is looking at smoking in the same study. What we have here is looking at the T allele and the CYP2J27 versus smoking in the CAD group. It looks for the presence of the allele and whether or not the person is a smoker. There isn't an association between smoking and CAD among the T allele CYP2J2 carriers. And this is looking at the CYP2C83 and smoking group. The results indicate the chances for CAD are 2.5 times greater to smokers. And this is just looking at the ANOVA test of male height in the group. So conclusions. The polymorphism CYP2C83 is more important for the occurrence of coronary artery disease compared with the CYP2J27 allele in the study. And there's a statistically significant association between the presence of the 2C83 and the smoking group with coronary artery disease. And you can see at the bottom the ANOVA test showing the difference in average height. So that's pretty much it. Just to say that genetic variation is quite important for this nature of study, and obviously there'll be genetic variations important, and we'll stay the same over time. Thank you very much for your time. If there's any questions, I shall refer you to Dr. Atanasova, who will happily answer them. Dr. Atanasova, would you like to come to answer any questions? There you go. Yes, sir. What was your question, please?
So, yeah, it's maybe quite a naive question. I mean, if it's genetic variation, so why did you recognize the difference between the smokers and non-smokers?
Yeah, it's a genetic variation. So why did you wish to separate smokers and non-smokers?
Because it would be more information, more informative. Yes. For
Yeah.
more data,
Yeah.
of course.
Just to provide some kind of background, additional information, I suppose. So,
Thank you for your presentation.
okay. So anything else?
So in other words, in order to be a smoker, you need to do full genotype.
Yeah.
Yes. Maybe we need more data. I think so.
We don't encourage the smoke.
Sorry, yes, go ahead.
Are you going to look at more parameters like alcohol and lack of exercise, all of these sort of things as well?
No, it is a good idea. Maybe in the future I will research this in this area.
Yeah, I guess my comment, I guess for me would be if you look for a genetic marker, it wasn't found to be statistically significant, but perhaps a combination of markers, some genetic, some lifestyle might be interesting. And then you look at an incidence ratio rather than a prevalence ratio. So you look to see if there was an incidence of disease related to a combination of genetic marker plus lifestyle or smoking. But that's complicated, and your variables become quite indistinguishable.
Yes, and combination between some genetic markers and mathematics models. It is very interesting to me.
Very neat.
Yeah, so maybe something to look at in the next stage.
Is there any other questions? No? Very good. Thank you.
Thank you very much.